This conference will now be recorded.
Welcome to everybody connected. As usual, I ask you a few minutes of patience because just to wait last attendees to connect. I hope you are doing all fine and that the situation in your countries is improving. Here in Italy, looks like situation is getting better and better. That we have fewer and fewer cases of COVID. So looks like we are in a stable, let's say, in a plateau situation. It's almost 50 people. Let's wait just another minute and then we start. Yes, Uzam, it's good news. It's really good news. Let's hope that the economy will also not suffer too much about what happened in the past weeks. Concerning all our operations, I confirm today also that even though we have a big backlog to recover, we are at full speed in the factory, in the warehouse, our suppliers. We have also the R&D people back in the laboratories, so things should be set up in the right way now. So it's 3 minutes after 11. I think we should start now. We are 50 people, 49. So everybody, today is the last appointment of our series of 7 webinars. I hope really that you enjoyed our initiative to, let's say, make a little bit the point on the main families of our offer, because it's really a lot of information, and having it explained by Stefano, which is our expert, and having it recorded also in YouTube, I think it can be a nice tool also for you when you have any doubt to clarify it immediately. So today we will talk about earth leakage relay. So we will talk about basically protection devices. Please, Stefano. As usual, me, I'm Matteo, export manager for IME. Stefano, our expert that will do the big part of this technical speech. Maurizio and Paolo in my team, they are connected and ready to answer to any of your questions. As usual, feel free to use the chat in any moment, place any kind of question, don't be shy, we will answer to any kind of question. So the agenda for today, basically an introduction from my side very quickly, then an explanation from the literature. It's quite technical, the subject today, quite technical, so it needs really a theoretical introduction from literature. Then we will explain it in detail what is actually an earth leakage relay. We will go through our range, concluding with our 2 last, let's say, launches, which are the earth leakage relay with communication and earth leakage relay also for direct current networks. At the end, we will have, as usual, many minutes, I would say. We'll dedicate, as usual, a big part of our time for the question and answers. So again, feel free to place your questions anytime. Okay, basically, this is what represents our ranges. So In our webinars, we did not touch 100% of all our catalog. Of course, we did not speak, for instance, of analog meters, also because they are a dated offer, even though they are, of course, they are still demanded by the market. But we started with the new range of energy meters. That it's a very important launch for us this year, because it's the launch of a new range after many years for IME. Then we spoke about the NEMO, the multifunction meters range. Then we spoke about a particular product inside the NEMO range, which is the NEMO 96EA, our power quality analyzer. Then we spoke about the web server, which is a very important device because it permits to add the software to the hardware, and to add, let's say, functionalities of supervision. We spoke about the NEMO S6 range, which is our system, actually modular, scalable system that permits to have not just measurement, but also monitoring with warnings and control of the electrical cabinet, and can be used, of course, in association with our web server. Then we spoke about our range of transformers, which is very big. You saw in the last webinar, and we especially, Stefano underlined in which way has to be chosen the right transformer depending on the features of the installation. Today, we conclude with the earth leakage relays, so with protection. So I really wish you to enjoy this last webinar, and we see at the end for the question and answer. Please, Stefano.
Thanks, Matteo. So, hello and welcome to our 7th and last webinar of this series. As already said by Matteo, I'm Stefano Chiarichini, Technical Commercial for Export part of IME Brands. Today we will present our earth leakage relay series called the Delta. But first I would like to introduce the concept of earth fault, the causes and the effect of these dangerous events. So, the earth fault is a loss of isolation between a light conductor and the ground. This represents a real problem because it could damage electrical installation as well as being a real problem for people. In fact, if a person were to come into contact with a normally non-conductive part, it could be found dangerous potential. Among the main causes of this loss of insulation, we find a decay of the insulation rubbers, mechanical breakdowns due to the accidental cutting of the cables, particularly aggressive environment with the presence of dust or humidity, or atmospheric events such as lighting, and last but not to be underestimated, the mice action. Well, what are the effects of these events? First of all, it is to bring the masses under voltage or to generate electric arcs and consequently an overheating, disturbance in telecommunication system, or a possible erosion of the electric earth rod. So a real problem for people and objects. Well, what can help us to prevent these events? Here the earth leakage relay comes in our help. The ELR is a protective device that detects the fault or loss of insulation and acts accordingly. Generally, it is going to release the main switches, therefore removing the voltage from the circuit. Thus, the threat of danger will be eliminated, safeguarding the safety of people and the object. What is made of? In the industrial field, the ELR consists in two devices, a toroid and a relay. The toroid has the task to detecting the current and returning into the relay. at the relay, you can set a differential current threshold, and if it reached, it trips. How it works? It's very simple. All cables or bus bar passed inside the toroid. A current will flow in each cable or bus bar. This current is represented as a vector. The toroid works on the Kirchhoff principle. The vector sum of the incoming currents must make 0. If it is different from 0, then we have a potential dispersion and therefore a potential danger. This current value is reported on the relay, which compares with the set threshold. And as I say, if the current exceeds this threshold, the relay trips and opens the supply circuit, removing the voltage from the circuit. So, where I can go to install this differential relay? Well, wherever I have an electrical circuit and I need protection. Some examples are safety circuit, motor and control circuit, light circuit, generator set, and etc. 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 I talked about any electrical circuit. I lied. Let's say that even here it depends, because in the world there are different types of electrical system. As introduced, the early fault, the earth fault, sorry, and the consequences derive from a contact between a live masses and the earth, called PE. But as I say, there are different type of system, called TT, TN and its variant, and IT. What does this letter indicate? As we see described in this slide, we find that each letter indicates something. For example, the first T indicates the direct connection of Earth to a point, generally to the neutral. The E, the A, the insulated from Earth or ground connection through an impedance. The second letter indicates how the masses are connected to the Earth. The subsequent letter indicates the status of the neutral and Earth and how it is connected. Let's go in deep for a moment. In the TT system, the neutral and the masses are connected to two electrical independent earthing systems. In the IT system, however, there are no active parts connected directly to the Earth, but can we have active parts connected to Earth through a high value impedance. All the masses are connected to an impedance to an independent earthing system. In the first cases, the TT system, ELR is a must. In the second cases, instead, could be enough an isolation relay. Going forward, we found the TNS system, in which the neutral conductor and PE are separated. For the TNC, the neutral protection function are combined in a single conductor called the PEN, while in TNCS, the neutral and the protection function are partially combined in a single PN conductor and partially separated PE plus N. It is therefore possibility to understand that in the first one it will be possible to use a ELR, while in the other two ELR it can be used as a backup, because a breaker can be enough. But let's take a practical example. Supposing we have an insulation failure on phase 1. In the IT system, the earth fault current return to the power node through the earth system at the masses and the capacities to the earth of the line conductor. For this reason, a simple insulation monitor is a must. In the TT system, the earth fault current return to the power node through the ground. Here, the ELR is essential. In the TN system and its variant, the earth fault current return to the power supply node through a direct metal connection, PE or PN, without practically affecting in the earth rod. in practice a short circuit. For this reason, a thermal magnetic circuit breaker could be enough. Well, in this slide, in this table, we find and summarize the various system indicated and the main application. For example, in the TT system, we found them in home system or in small industry that use only low voltage. For the TN system, instead, powered in large industry or in medium voltage. And the last, the IT system, widely used in plants where I have to guarantee the continuity of the service, such as chemical plants or petrochemical plants industry. Well, now we have introduced the various type of system. So now we have to worry about what we are measuring. Yes, because load that need current can deform the waveform. For this reason, on the EN 60947, the standard that define 3 different type of differential. The type AC, A, and B. The ACs are capable of reading sinusoidal waveform with only alternating components. Adding load that operating on pulses, such as a welding machine, add unidirectional pulsation current. The type A is able to trip if these differential currents are detected. If instead we have a large server room where a capacitor can contribute with a direct current, here I need a type B. Well, what does the Immer offer? Immer offer a range called delta, able to satisfy most of the market needs. We will find in the catalog different formats from 2 to 4 DIN, rather than flush mount like format 96 for 96 millimeter, or 72 for 72, or 44 for 48. 48, sorry. In some cases, the device have an indication of the percentage of differential current detected, and in some cases, a communication in RS485. For the rail instrument side, we found from 2 to 4 modules, which are mainly different from the quantity of alarm, 1 of 2 alarm, and from the percentage indicated through a LED bar. All these range are for the type A and AC. For the flash mount, we find a different dimension, as mentioned a little while ago, and also here a possible bar indicated the percentage of differential current with respect the set threshold. In the range, there is also a model with a display capable of displaying the differential current value. The instruments mentioned so far are in class A and AC. In our range, we have some relays with a reinforced analog filter in support. What does it mean? If you have a sinusoidal waveform line, which therefore falls under the type A or AC, but characterized by a strong harmonic component, a normal relay could have an untimely trip or generate a false alarm. This filter cleans the waveform from the harmonic component and help in many cases where I have untimely trips. Well, how I can configure this instrument? Very simple. On the left, there are the button and dip switches that you generally find on differential. Change the layout a bit according to the format, but in general, they are all there. On the right, we find what everyone means. What should I do? First, I have to go to set the intervention threshold from 0.03 to 0.3 amps. Second, I set the multiplier of this threshold, then setting a value ranging from 30 milliamps to 30 amps. Select if I need an automatic or manual reset. So when I reach the threshold and the fault appears, I want the ELR to reset automatically or in manually way. Next, select the type of alarm, for example, in positive or negative safety. What does it mean? In positive safety, when I power up or shut down the relay, the alarm changes the state and change it again when it trips. The negative safety, on the other hand, when I power up or shut down the relay, the alarm does not change the state, but only change it when I reach the threshold. Last, I have to set the delay for the intervention. Remember that the level of life saving for people is 30 milliamps without delay of the intervention. So, special mention goes to one of the last born of the Delta family, is the Delta D4H. In addition to the classic and, as already mentioned, the parameter, it is different from the RS485 port, which allows you to remotely operate, reset, and control the differential current on an enhanced filter for digital harmonic. This is more or less the link between the type A or AC and the type B, where we will show you later. Well, but an ELR isn't only a relay. To detect the differential current, there is a toroid. This toroid has different diameter for a different cable or busbar. We go from 28 mm to 210 mm for closed core toroids, to 110 mm to 310 for open core toroids. Each toroid is characterized by a nominal current and a minimal detectable differential current value. In according to the EN 60947, in application with high transient currents, I can take as reference 6 times the rated current. So, how do we choose the correct toroid? Well, first of all, I have to know what is the differential current value at which I want to set the threshold. After, I have to choose a hole, a window, that able to embrace all the cable or busbar in an agile way. In fact, I have to pass of the cable inside the toroid, trying to center the conductor as much as possible. Be careful not to let the earth conductor pass inside the toroid. If, in other hand, you have a shielded cable connected to PE, to the earth, pass it back inside in order to cancel its contribution. What if I can't embrace all this cable, all this busbar, and why, for example, are they far away? Here, a summation toroid come in our help. The installation is done by connecting normal CT, standard one shown in the last webinar, with the rated current is closest to the maximum current that could pass, connected then in parallel and all together, and go to the added toroid. This toroid will connect to the relay. Well, a mention was also made to the release monitor, called Delta TCS. This device monitor the trip circuit of 1 or 2 relays and report an alarm if it finds a disconnected or a non-functionality current launch coil. And for the type B, IME also recently added a type B model. I remember that type B is a tripping, is assured for differential current continuous, as well for the sinusoidal alternating currents differential and for unidirectional pulsating differential current. Our device is a modular residual current device, which do not integrate a current breaking device. It is intended to be used in conjunction with the circuit breaker. In this slide, we find the difference between a classic RCD with the integrated breaker and our MRCD, able to work with all the breakers that guarantee the compliance with the EN 60947, the standard, such as disconnection within 40 milliseconds. This type B is equipped with the 2 output relay, 1 pre-alarm and 1 alarm, and the display capable of showing the instantaneous current values, the set threshold, and the interface delay. For this series, there are 4 dedicated toroids to monitor the line up to 630 amps. These toroids are different from the classic type A or type AC. As I say, type B must be able to read both alternating and direct current. For this, inside the toroid, we find 2 core and 2 winding, precisely one for continuous component and the other for the alternate. Here too, we find a different holes or window and different diameter to pass the cable or the busbar. Based on the hole chosen and the nominal current of the system, there will be a minimum differential current that can be detected and set the relay, like the AAC. Not only. In fact, on the upper part, there is a 3-position rotor in which we have to set the same differential current value you set on the MRSD. The connection between the toroid and differential take place via 6 wires. 2 will be for the AC core, 2 for the DC core, and 2 for powering the hardware component present on the toroid, because it is also an active part to detecting the fault. The central rules of the conductor remain the same for the AAC toroids. Well, where I can install this type B? Wherever there is a possible continuous component that can distort this waveform. Some examples are in situ present in medical devices, the most common inverter for a photovoltaic system, lift, welding machine, as I say before, electrical charging station, cranes, and last but not least, the UPS. So in every single case where a continuous can go into deform or make an added component to the waveform of the alternate current signal. Well, I think we come to the end. So as we know, an earth leakage relay is an essential protection if I have a system that allows me to install it, to avoid the multifunction and damage to the people or things. As always, I leave you some useful links about technical note, the brochure of the new Delta, the updated technical note for type B and the manual, and the bestseller catalog where you find all the bestseller and ready to sell the differential relay and the toroids. So for today, I think it's all. I leave the word to Matteo for the question and answer.
Thank you, Stefano. We did not receive until now many questions. I just go through what was asked. The first was from Marco. Is there any equipment that includes RS485 communication?
Yes, the Delta D4H. We find in this slide is one of the last added to the series. Is this one? You can remotely the current, the differential current, so you can see the differential current remotely. You can find the protocol on our website, or if you want a ready-to-use software, you can use our EDM Evo software. So you can remotely see the current, the differential current, but also reset or test the relay.
Okay. From Carlos, is there any standard that we should follow regarding the way to pass the cable through the toroid, for example, that defines the distance to internal toroids?
No, there isn't generic rule. As I say, it's you have to choose the differential toroid that you have to pass all the cable or bus bar in agile way. So you don't have to constrict the cable to the differential toroid, but more or less 1 or 2 finger pass from the cable and the center of the toroid or the cable you center. And what is you mean? You know, in English, Matteo, fascette. How do you say?
Yes, these plastic strips that you use to block electric components, let's say.
Perfect. The conductor and to center to the toroids.
Okay. From Marco. For equipment with harmonic filters, what is the maximum level of harmonic distortion of current allowed?
So up to 25th harmonics. So up to 25th harmonics, it clean the waveform. Pay attention that in many cases, I have to use this reinforced filter only if I'm sure that my line have a lot of harmonic content. That come in our help, for example, the NEMO range, the multifunction that you show what is the harmonics content in my circuit. Because
just a second.
Because if I don't
Kogo, shall be our work.
If I don't have the certain that is a problem of harmonics.
Sorry, can you please shut your microphone?
Okay, thank you. Sorry. As I say, if I don't sure that it's a problem of harmonics content, I can untimely untrips for a real problem. So I am sure that my circuit have a lot of harmonics content. For example, in my circuit, I have an old device that I can change it, and a minimum of differential current flow because I have old masses that no one person can touch these masses. So I am sure what I have to do before select a reinforced filter.
Going back to the previous answer, Stefano, the right wording is cable ties, okay? Cable ties, perfect. Okay, cable ties. From Marco, are videos available of these equipments?
No, for the moment, no. For the moment, I don't know if marketing can generate YouTube tutorial to use, etc. I don't know. For the moment, I don't know. But as I say, the configuration is very, very simple. You have only 4 parameters to set on differential relay.
From Mohammed, I heard the mixed topic of earth fault and earth leakage. Could you please differentiate?
Sorry, can you repeat?
Looks like for Mohammed, the concept of earth fault and earth leakage is 2 different concepts.
Okay.
So how do you, in your experience, how do you differentiate?
Okay. So as we say, depend on the type of system used. With different system, you have different type of earth leakage or earth fault, because you have a loss of dissolution or a short circuit. So depend of which type of system you have. That's why you have to use or not use the ELR. Because depend on which system you have. So in the system you have a earth leakage or a earth fault.
And also the devices change depending on the system?
The devices is the same, but you have to use or not use a ELR depending on the system. For example, as we say, for the TN system, you don't have to use, or better, you use only for backup or for only certain type of load. You don't have to use the ELR because a loss of insulation between one conductor and the neutral, for example, is a short circuit. So you don't have to use the ELR, you have to use a thermal breaker.
Okay, from Boris, what frequency range are covered by the differential transformer?
All the standard range of the IME instrument, 47 to 72 Hertz.
From Beat, the relays also works when it's used a frequency converter.
Yes or no, depends if it is in this range, because it is out of this range, it is out of the standard norms, so it can you can have an untimely trips. So if it is work under the frequency, as I already say, in this range, yes, it's work. Is go over or under this range? Probably not, because you have an untimely trips.
From Hussam, can we have a training for using your software application? But in this case, Stefano, I think we can make something dedicated. I mean, we can think for a future webinar, maybe in a second wave of webinars where we go in detail in the software if you want, if you think this is useful. Meanwhile, we can organize with any of you some dedicated Skype or Teams training, no problem.
Perfect.
From Pablo, I think I know the answer. This answer. Do you have the type F in your range? Yes, we have, right?
No.
I know it's the F. It's the F at the end. You are right. It's the F at the end.
Reinforced. In our range, we have A, C, and B. I have to read the norm about the type F, because the type F is, I think it's a borderline. I think it's not defined on the norms. I have to check. Really, I have to check, because for type F is like our F range, because they remove the harmonics component from the default. But I have to check if type F is regulated by norms. As I say, the most similar type F from our brands is the Delta D4H, because you have a digital harmonic filter that can clean the waveform from this harmonic content in very good way.
So we will go back, come back to Pablo after your check on the norms.
Okay. Yes.
Okay. From Hussam, how is working with motorized MCCB and ARCB?
So the relay is only a chip, is only a contact that open or closed, depended on or when or how it works MCCB or RCB. So when you have a normally open or normally closed, when you you go over the threshold, so you reach the threshold of your current differential relay you set, it's open or closed. So as I say, normally open or normally closed, the alarm. These go to a coil, a minimum voltage coil or a launch current coil, and these go to operate to MCCB or RCB.
Okay. From Boris, do you have a filter function to select only 50 Hertz for no influence from sorry.
As I say, is the type F, not type F, is the F series, the delta D4H and the F series. The F series take only the nominal frequency, the 50 Hertz or what is the frequency how it work, because it's working 60 Hertz, it take only the 60 Hertz.
Okay. From Marco, the delta D4H equipment is compatible with energy management system and web server 32 or 255 points?
For the moment, no. For the moment, no. But I think marketing working on it, if I remember well. I have to check all of this, but if I remember well, yes. But I have to check. For the moment, no.
Okay, so we will come back to Marco to check if the current version of web server 3.8.1, which you find since Monday on the website, can also manage delta D4H.
Yes.
Okay. From Rajesh, is there a comparison table or chart of our earth leakage relays towards others? How we differentiate better than others? Some sort of advantages in our range and argumentary highlights.
So if we have a table,
if we have some comparison to show if our range has something differentiating from the market, let's say.
Okay. We can generate it. Write me an email. I can show the on this presentation the competitor, but we can generate it. It's not a problem.
Okay.
Write us an email to me, or Paolo, or Maurizio, or Matteo, and we can generate this target table.
From Rajesh again, as earth leakage relays is a very competitive product. Okay, no, it's to complete the previous comment. I think it's something like there is quite a stress on the price probably, and but Rajesh thinks our range is competitive, so probably an argumentary can be a useful selling tool for him. So I think we can work on something to help our customers to propose the offer.
Perfect.
That's it for the moment. We have still 15 minutes, so I think we could take advantage of this. If you want to make questions also on the previous webinars, if you have maybe you have made some check on the recorded webinars, maybe you have used the devices regarding other ranges. If you have any questions, feel free also to place it. We are here to answer to you. Or Stefano, if I think if you want, we can also use some minutes if you want to explain the hospital range, maybe
yes.
just from the website.
Okay, as we say in for the in the IT, for example, in the IT system, you can use the isolation relay. I can show you in our range we have H41. We have an isolation relay that can control the isolation between Hertz and a conductor. So is this one. As you can see, you have to connect this isolation relay to the transformer, to the isolation transformer. It's very useful in these cases where, for example, into an hospital, if you have I want to say sala operatoria, operator.
A chirurgical room, something like this.
Rooms, for example, you have to you need to have the isolation from the surgery room from the external of the hospital, because if you have a loss of isolation on the masses, you can electrocution on the patients. So it's very important that your surgery room is isolated from the rest of the hospital. So you have to use this instrument. As you can see on the wiring diagram, you have only to connect this instrument from the PE to the line, and you have be able also to connect a PT100. It's what to say, sonda, I don't remember sonda. It's
sensor.
It's a sense, a temperature sense that can
probe, temperature probe.
Sorry, a probe, a temperature probe that can avoid from overheating of the transformer. You can also integrate or connect a current transformer that can maintain under control also the current value that flow from the isolation transformer. That's all for the current transformer. I see there are other two questions.
From Hossam, before from Hussam, please can you send all webinar from day one up to date? Actually, in if you want to put the link, Stefano, but we have in YouTube all the webinars. So Hussam, you can go just to where Stefano is showing.
Yes, sure.
And you go in our website in the English part, in the news, and you will find
English.
Okay, newsletter. Sorry, news plans. Sorry. Okay, and the webinars. In the lower part, you have watch with previous webinars. If you click there, you go directly on YouTube. On YouTube, you find all the 7 webinars recorded, as you can see. Okay. For higher ratings like 2000 ampere, what kind of 2000 ampere breaker? What kind of earth leakage relay and toroid can we use?
You can use a normal earth leakage relay, but if you have 2000 amps, normally you use a bus bar. As we say, you have to use a summing rings. So you have to connect for every single bus bar a normal current transformer that can embrace every single line plus neutral if you have a neutral, connected in parallel to the summing transformer. This summing transformer works like a normal current transformer toroid and connected to the ELR.
From Hussam is asking if we give, let's say, can give some instruction or tips about what's the best way for saving energy and audit. Here, of course, I have to say that as you saw in the previous webinars, especially the ones related to web server and NeMo SX, what we have is a solution, hardware and software, that will permit you to check the consumption, and also with NemoSX to make automation to save energy. Then, if you want to make an energy audit, this is a very special activity. So you need, I think, find partners in the market, like energy service companies, that do this work, this job every day. So the expertise of the energy auditing is something very particular. Of course, our solution, both hardware and software, can be very useful for the energy auditing and also to check after some interventions are made on the building or on the factory, to check in time what the savings are. I hope this clarifies a little bit the question. Dina, this is something more general about protocols. Could you explain difference between Modbus and Embas?
Sorry, what is the difference from Embas and Modbus?
Yeah.
But there are two different protocols, so there are two very different protocols. So, so for energy metering. So, I give you a simple example to try to understand what is the Embas and Modbus. For the Modbus, you have a map that you can go to make a query to the instrument, and the instrument give you an answer about the register or the all the register or the list of register you have. If for the Embas, however, you have a telegram, you ask to the meter a telegram, is like a letter, that the instrument give you an answer with a letter compacted in a certain way, that the master that make the query to the instrument understand this telegram and keep the information you need. So you are two different type of protocol to speak with the instrument.
Okay. There is a comment from Rajesh, which is, let's say, talking about Midasevo. I want to make a clarification about this. So, Midasevo is a software that was used especially in the past years, where we are developing, let's say, our software solution is the web server that was explained in one of the previous webinars by Stefano. So if you have a current installation where Midasevo is needed, of course we can support you, no problem. But pay attention that for future installations, starting from the new range of energy meters, Midasevo will not manage the new launched products. So please try to switch for new projects to the web server. This is the advice that we give you. From Stilian, where can we find the Modbus register?
In our website. You can find, for example, as you said, for the Delta D4H, you have to go here under Documents, Technical Data Sheet, and click select the code RDD4. On RDD4, you have Technical Sheet, Manual, and Protocol.
Okay. Dimitris, regarding isolation transformer and technical notice 699, better if you open it.
The 699.
Yes, NT 699. Yeah. Okay, basically, I read the question. Maybe you know it by heart. In page 2, it states setting up with screen and wiring diagram. There is a connection name screen N. Page 2.
Page 2. This screen N.
Yes.
Where?
The screen N, where there are the transformer terminals. What should we connect there, and what should we take care of? So should be an N in the connection to the terminals somewhere.
Screw terminal. This screw terminal.
It's talking about an N.
Probably skin. I don't know.
I don't see it either.
I don't know. Try to write me an email. I answered via email.
Okay. So Dimitris, write an email, please, on this particular point. But I think it's all. I don't see any question more. So thanks a lot for your participation to these webinars. We hope you appreciate it. It's not finished yet, in the sense that what we will do now is we will prepare a test regarding all the 7 topics that we treated, and we will send the test to you. You will have some days to answer. And based on the test result, we will create a very nice certificate of IME expert, certified expert, that you can use on your website. You can put on the wall in your office, as it is something for us. It's not just a paper, of course. It's really some link to us, to our brand. So it is an activity, something we want to do to close these webinars, in order, one, to verify that all the concepts, the many concepts that Stefano passed to you, have been very well, how can I say, absorbed by you. And the other point is really to create, reinforce the link between us, between the brand IME and you, because you are our force, let's say, on the market. So without you, we don't go very far. So thanks again, and we are always, even if this series is ending, maybe we can think about a new one, a new wave of webinars. So feel free to send your needs, your ideas. We can study for the future a new range of a new series of webinars. And in any case, we are here always to answer to your questions. If you need, you have doubt on how to use the software, as I said before, we organize very quickly a Skype, a Teams meeting to share the screen. Stefano can show you the steps. So feel secured by our presence, because we are there to help you in the business. So thank you very much again, everybody. It was a great pleasure for me to participate to this initiative, and I thank Stefano for the great activity done. He's our expert. He showed his value, and I think you agree with me that he's really a great technician.
Thank you, Matteo. Thank you.
Thanks again to everybody, and see you soon.
Have a nice day, and thank you.
Bye guys. Bye.
Bye Matteo.
Ora si registrerà la
Arrivederci,
conferenza.
my friends.